Alright everybody, what's going on? This video we're going to look at double integrals in polar coordinates. Alright, so let's go ahead and get started. Alright, so just a quick review. So if we have, we've got an angle here, theta, and we've got, this is x, this is y, here's r, and of course that's a right angle there. And we have a point here, pxy. This is in rectangular coordinates, and you know we can convert it to polar coordinates, r theta, where we use this right here. R squared is equal to x squared plus y squared, x is equal to r cosine theta, and y is equal to r sine theta. You've done this before, so just keep this in mind of how to convert to polar form. All right, so looking at polar coordinates. All right, so let's suppose we have, okay, so if we look at this over here, so we've got an angle here, and we're breaking this area up here into little squares. And okay, so this angle here between each one is delta theta. All of these angles here, they're the same. They may not look it, but they're supposed to be. And we have this region r sub ij, and basically what we're doing is we're finding this area here, okay, and we can sum all these up, and if we have a surface over it, we can get the volume underneath the surface and above this area right here. And so we've got a point here, r sub I, theta sub j, and this is theta j, theta sub j, this is theta sub j minus 1, and then we've got the radius here. This radius is r sub j minus 1. This is r equals r sub j. And so, you know, if we take this little part right here, just this right here, we can bring it over here and kind of blow it up some. So we've got here r is equal to b, here r is equal to a. This is the radius out to there. This is your region R, this is alpha, and here theta equals alpha, and then if we go over to this side, theta is equal to beta. All right, so let's look here, change to polar coordinates and a double integral. So if f is continuous on a polar rectangle R given by, so 0 less than or equal to a, less than or equal to r, less than or equal to b, okay, and theta is between alpha and beta, where beta minus alpha is between 0 and 2 pi, then the double integral of the region f of xy dA is equal to the double integral alpha to beta a to b of f of r cosine theta, r sine theta, times r dr d theta. So you're basically you're taking this function here and you're converting it to polar. Now make sure you don't forget times this r right here. Okay, make sure you don't forget that. That's left out a lot. A lot of students, they'll take this function here and they'll convert it, and they'll write this function down and then dr d theta, and they'll forget that r there, but make sure you don't forget that r. So let me just show you this this part right here. Let me show you how that comes in, how we go from this to this. All right, so let's suppose we have, So this right here, this is d theta. All right, and then we've got r right here, your radius, your radius here. And then this right here, this is dA. All right, this is dr. Now, we can look at this as like finding the area of a square or a rectangle. So what would be the length of this right here? Well, remember the arc length is the radius to here times the angle, right? So this length here, that would be what? R times d theta. And so that would give me dA is equal to, well, it's this length times this length. So it's r times d theta times dr. All right, so all I did is I did this length, which is r d theta, times this length, and we can write it as r dr d theta. See, there it is, r dr d theta, and there's your dA. All right, so let's look at an example. All right, so it says evaluate the double integral over r of 3x plus 4y squared dA, where r is the region in the upper half plane bounded by the circles x squared plus y squared equals 1 and x squared plus y squared equals 4. All right, so we've got our region. That's going to be the set of all x, y, such that, so we've got y is greater than or equal to 0, and we've got that this x squared plus y squared is between 1 and 4. Okay, because this is a circle with radius 1, this is a circle with radius 2. So we know this thing here is going to be between 1 and 4. All right. So what we need to do is we need to convert everything to polar. All right. So to polar form. So let's just sketch the graph. All right. So let's draw this. That's going to look something like this, because remember it's the upper half plane, and so it's just the upper part. And then let's draw this one, and so that's going to be this. And so what we're looking for is this right here. All right, so we know this is 1, this is 2. So let's set up our integral. Okay, so we've got the double integral over r of, I'm just copying this down again, 3x plus 4y squared dA is equal to, all right, so it's the double integral. So we've got what? Well, this is going to be, what's going to be the bounds on this integral? All right, so remember up here, see I've got dr here, so the bounds in here are going to be for r, and the bounds out here are going to be for theta. And so we can see that theta is going from 0 to pi. So 0 to pi. And then the bounds on r, that's going from what? 1 to 2. 1 to 2. And that's going to be of what? that's going to be of 3 times r cosine theta, right? Because remember, x is r cosine theta plus 4 times, and then y is what? R sine theta. That's going to be r sine theta squared. And then remember, times r times dr d theta. And so this is going to give us 0 to pi, 1 to 2. I'm just going to kind of rewrite this. This is going to be what? 3. And I need to put a parenthesis around that whole thing because this is times all of this. So that's going to be 3r squared cosine theta plus 4r cubed sine squared theta dr d theta. Now see here, I've got r squared, and then r times r squared is r cubed, and r times r is r squared. All right. All right, so let's see what we've got. So we've got to do what? We've got to integrate with respect to r first. All right, so this is going to be 0 to pi, and this, the antiderivative of 3r squared, that's going to be r cubed cosine theta plus r to the 4th sine squared theta, and that's going from 1 to 2 d theta. All right, so what does that give me? That gives me 0 to pi, and this is going to be 2 cubed cosine theta plus 2 to the 4th sine squared theta minus, okay, so I plugged the 2 in for r. Now I got to plug the 1 in for r. So that's going to be minus 1 cubed cosine theta plus 1 to the 4th sine squared theta d theta. And so this is going to be 0 to pi. All right, so let's see what we've got. So this is 8 cosine theta minus 1 cosine theta. That's going to be what? 7 cosine theta. And this is going to be 16 sine squared theta minus 1 sine squared theta. So that's going to be plus 15 cosine. Not cosine. 15 sine squared theta d theta. All right, so we've got it simplified. We combined our like terms. And so now I've got to integrate this. Well, this one right here is easy to integrate, okay? But what about this one? All right, so remember back when you first started, well, not really first started learning integrals, but when you did trigonometric integrals, you remember you had that property that said sine squared theta is equal to 1/2 times 1 minus cosine 2 theta. Your half angle identity from trig. Okay, so we'll have to use this. We'll have to use this property right here. So that is going to give us 0 to pi of, and let's just go ahead and do this. Let's split this up. So that's going to be 7, 0 to pi. I'm going to bring the 7 outside. Cosine theta d theta, and that's going to be plus 15 integral 0 to pi. Now I'm going to replace this with this. So it's 1/2, but I'm going to bring the 1/2 outside the integral, and that's going to be 1 minus cosine 2 theta d theta. I don't think I ran off the screen, but if I did, if you can't see this, that's d theta. All right. And so let's do a little more work here. So 7 0 to pi cosine theta d theta plus 15/2 0 to pi of d theta. So I'm going to integrate each one of these individually. Okay, I'm going to do the integral of 1 minus the integral of cosine 2 theta. So I've got the 15/2 goes to both of them, and that's going to be minus 15/2 0 to pi cosine 2 theta d theta. All right. So now I'm ready to integrate all this stuff. So, well, that's easy there. That's 7 sine theta from 0 to pi plus 15/2 theta from 0 to pi minus 15/2. Now, here we need to use u substitution. So here I'm going to let u equal 2 theta. So du is 2 d theta. All right. Now, what's happening here? See, I've got the d theta. I've got a d theta. I'm missing the 2. So I need a 2. So I'll multiply by 2. So that means I have to come out here and multiply by 1/2. That's the same thing as multiplying by 1. And so this is actually going to give me 15/4 0 to pi of cosine u. Oh, I'm sorry, not 0 to pi. Let me do that in a minute. Replacing the 2 theta with u, and then the 2 d theta I'm replacing with du, and that's du. All right, now I've got to change my limits. See, I was in theta here, but now I'm in terms of u. And so that's going to give me u is equal to what? 2 theta. So 2 times 0. I'm going to take the 0, plug it in for theta. That gives me 0. And u equals 2 theta. And in the place of theta, I'm going to put pi. And so my limits are 0 to 2 pi. And so this is 7 times sine pi minus sine 0. Okay, I'm going to go ahead and work these. Plus 15/2 times pi minus 0 minus 15/4. And the antiderivative of this is sine u from 0 to 2 pi. And so notice this, sine of pi is 0, sine of 0 is 0. So all of this right here goes to 0. And so this is what? This is 15/2 pi there. And then this part right here, now I'm working with this, so that's going to be minus, and that's going to be, well, let's do this, minus 15/4, and that's going to be sine 2 pi minus sine 0, and that worked out nice because this right here, this in here is 0, so this whole thing goes to 0, and so I just get 15/2 is my answer. All right, so you know it's not too bad. There's a little work involved, but you know it's not difficult to do. You just convert everything to polar. All right, so let's look at this next one. So we want to evaluate the double integral -1 to 1, 0 to square root of 1 minus x squared plus y squared dy dx. All right, so we could absolutely work it like this, but I think what's going to happen after you integrate this part of it, which isn't that bad, then you've got to plug this in for y. Okay, and what's going to happen is you're going to have something nasty to integrate. Okay, I think you'll end up with I can't remember, but you end up with something that's not very. I don't think it's very easy to integrate. So, but anyway, that's why we have polar coordinates. It can make some problems, easier to work. So let's change it to polar. So right now what we have is we have the set of all x, y such that, so we've got x is between -1 and 1, see that? And we've got y is between 0 and square root of 1 minus x squared. That's what we have right now. So let's convert this to polar coordinates. And before we do that, or something to help us do that, is just kind of maybe sketch a picture of it. All right. So notice here we've got y is 0 to square root of 1 minus x squared. All right, so look at this 1 minus the square root of 1 minus x squared. That's what kind of a region is that? Well, that's the top half of the circle, right? Right there. And it's -1 to 1. All right. And so, there you got it. This is 0 here. All right, so let's go ahead and set up our integral. So I've got -1 to 1, and then 0 to, I'm just copying this down again, 0 to square root of 1 minus x squared. And it's x squared plus y squared, x squared plus y squared, and it was dy dx. All right, so let's take a look and see what we've got. So this was our region here. Let's write it. We've got everything. We're going to get everything in polar coordinates now. So that's the set of r theta such that, now look at this. What is r between? R is between 0 and 1, right? And theta is going from what? 0 to pi. All right. So this is going to be the double integral. All right. So what coordinates are going on the outside? That's going to be your theta. And then r limits are going to go from 0 to 1. So theta, the limits for theta on the outside, the limits for r on the inside. Now, we've got to convert this to polar form. Well, x squared plus y squared is what? R squared. And then it's times, so this r squared, that's your x squared plus y squared. And then we have what? R times dr d theta. All right. Don't forget the r here. And so this is going to be 0 to pi, 0 to 1 of r cubed dr d theta. And then we integrate this one. This one's actually pretty easy. So that's going to be 1/4 r to the 4th from 0 to 1 d theta. And so this is going to be 0 to pi of 1/4 times 1 to the 4th minus 0 to the 4th d theta, which that's going to be 0 to pi, and that's going to be of 1/4 d theta. See, this right here is just 1, so we're left with just the 1/4. And so we integrate this. That's going to be 1/4 theta from 0 to pi, which is 1/4 times pi minus 0, which is just pi over 4. And there's your answer. All right. All right, so let's take a look at the next example. Got a lot of examples in this section. All right, so find the volume of the solid bounded by the plane z equals 0 and the paraboloid z equals 1 minus x squared minus y squared. All right, so let's see if we can't sketch this graph. All right, so we know we got a paraboloid. It's opening down. Okay. Now, it says z equals 0. So if we say, okay, z is equal to 0, then that means that we have x squared plus y squared equals 1. See, if we take the 0 and plug it in for z here, that's 0, and then we move the x squared and y squared over, we get x squared plus y squared equals 1. Okay. And the paraboloid intersects the circle x squared plus y squared equals 1. That's the circle that's going to intersect. All right, so let's draw. Let's see if we can't draw this. So we've got our circle here. Let's see, I don't know how good I'm going to be able to draw that. Maybe there's your circle, x squared plus y squared equals 1. And you're going to have your paraboloid going to come like this, and then it's going to go back here, and then you're going to have it here, and then it's going to come right here. So there's your paraboloid. And notice we have, if you're looking at this from the top in the XY plane, it's just a circle with radius 1, right? See, this is 1, there's 0. Okay, so this is what we're looking for. All right, so we need to find the volume. So the volume is equal to the double integral of 1 minus x squared minus y squared dA. All right, so I'm just integrating this over the region D. Okay, so we could set it up like this, and I'll actually, after we work the problem, I'll set it up leaving it in rectangular coordinates. But let's go ahead and convert it to polar coordinates, work that out, and then I'll set it up in rectangular coordinates. We won't work it out though, but I'll show you what it would look like if you did set it up in rectangular coordinates. All right, so this is equal to, now remember what goes on the outer integral. That's going to be your theta. So look at this. We're going all the way around. We got a complete circle here, so that's going to go from 0 to 2 pi, and then our r is going from 0 to 1. All right, and now what's our function? Well, we have to convert this to polar form, and so let's see, I'll do it right here. We got 1 minus x squared minus y squared. Well, that's equal to what? 1 minus x squared plus y squared, right? If I factor out a negative. And so if we do that in polar form, that's 1 minus r squared. And so I'm going to replace all of this with 1 minus r squared, and then don't forget times r times dr d theta. And so this is going to give us 0 to 2 pi, and that's going to be 0 to 1 of r minus r cubed dr d theta. All right. And now we just integrate this, which this should be pretty easy to do this. So that's going to be 0 to 2 pi, and that's going to be 1/2 r squared minus 1/4 r to the 4th, and that is from 0 to 1 d theta. All right. And so now we have 0 to 2 pi, and that's going to be, let's see, that's going to be 1/2 times 1 squared minus 1/4 times 1 to the 4th minus, now once again we plug the zeros in, that's just going to be 0, and that's going to be d theta. And so that's going to be 0 to 2 pi. And then let's see, what do we get in here? That's 1/2 minus 1/4. That's just going to be 1/4 d theta. So that worked out nice. And so this is going to give me 1/4 theta from 0 to 2 pi. I'm integrating this now with respect to theta. And so that's going to be 1/4 times 2 pi minus 0, which is pi over 2. And there you have it. All right. So what if we set this up in rectangular coordinates? Remember, we got 1 minus x squared minus y squared, and we've got x squared plus y squared equals 1. Okay. And here's our circle. Okay. So remember, the top half of this circle is y equals the square root of 1 minus x squared, and this is y equals negative square root of 1 minus x squared. Okay? And we're going from what? From -1 to 1. So if I were doing this in rectangular coordinates, so for rectangular, all right, so that would give me the volume is equal to the double integral. All right, so this is going to be -1 to 1, because remember your constants, they're going to always go on that outside integral. Well, let me write this first. All right, so that's going to be -1 to 1. And then the inside, that's your y value, right? Your g1 and g2, remember that? So that's going to be negative square root of 1 minus x squared to the square root of 1 minus x squared of 1 minus x squared minus y squared, dy dx. And so that's what we would have. And just to show you, if you were to do it this way, which you can, okay, you can do it this way, but what'll happen, it will involve finding this integral. After you integrate and you plug these in, you'll end up having to find this integral, 1 minus x squared raised to the 3/2 dx. Okay, and this is, do you want to integrate that? I don't know, we may do trig substitution. Okay, that would maybe be something you would try on that in trig substitution. And do you really want to do that? No. So what we do is we convert it to using polar coordinates. Okay. All right, so I hope that helped. Hope that made sense. All right, so let's look at this. So if f is continuous on a polar region of the form d is r theta, such that theta is between alpha and beta and r is between h1 theta and h2 theta, then the double integral f of xy dA is the double integral alpha beta h1 theta to h2 theta of f of r cosine theta r sine theta, and then of course don't forget the r times dr d theta. So let me just show you real quick what they're talking about. It's similar to what we were doing, what we've been doing. The picture looks similar, but look at this. It's a little different. I don't know, my drawings aren't that good. Okay, so well, no, that's not what I wanted to do. And so what you have are regions like this. They're curved. So this would be r equals h2 theta. This would be r equals h1 theta. We got some function here. And here we've got theta equals alpha, if this is alpha, and here we've got beta, so this is theta equals beta. And this is your region D, and we're integrating here. Okay. All right, so that's what you're looking at. So you can see it's similar, but remember they weren't functions right here on the ends for R. All right, so let's look at this. We've got taking f of xy equals 1, h1 theta equals 0, and h2 theta equals h of theta. All right, so in other words, this right here, it's here. It's not away from the origin. It's 0. Okay, in this formula, we see that the area of the region D bounded by theta equals alpha, theta equals beta, and R is equal to h theta is what? Okay, well, let's go through it and see. All right, so we've got AD is equal to the double integral d of 1 dA. Okay, so we've got f of xy is equal to 1. There's my 1 right there. Now I'm gonna convert this to polar. All right, so I've got my theta is going from alpha to beta, and R is going from what to what? It's going from 0 to h of theta, 0 to h of theta, and then that's 1, and then that's times the what? Dr d theta. And so this is going to give us alpha to beta, and that's going to be 1/2 r squared. Well, that should be a dr right there. From 0 to h theta d theta, which this is going to be alpha to beta of 1/2 times h of theta squared minus, and then look, when you plug the 0 in, that's going to be 0. So we'll just leave it like that, and that's d theta. So this is actually going to be 0 to beta 1/2 h of theta squared d theta. And so that's what you get there. It's the function squared, and then it's the integral. Oh, why am I putting 0? That's alpha. All right. All right, so let's work an example. Okay, so notice what this says. It says we see that the area of the region D. Okay, so it's the area of the region. So let's look at this one. All right, so it says use a double integral to find the area enclosed. So they're looking for the area enclosed by one loop of the four-leaved rows. R equals cosine 2 theta. All right, so let's sketch that. Remember back in, if you're in the Stewart book, it was back in chapter 10 when we worked with, I think it was chapter 10 when we worked with the polar coordinates, and you actually graph those polar equations in there. This is a four-leaved rows, And so if we sketch the graph, you will get something like, let me draw that again. I know that doesn't look very good, but they're all supposed to be the same. I know they don't look it. And then remember we have pi over 4 and we have negative pi over 4 when you were graphing those things. All right, so let's see what we have here. So you can see we've got our region. So look, we're just looking for, and look, we're going here. Okay, we're going from the center out to this graph here. All right, there's our radius. You can see as we're moving, as theta's going around like this, that radius is changing. Okay. All right, so that region is the set r theta such that, so theta we can see is between negative pi over 4 and pi over 4, and r is between what? 0 and what's that radius? Well, that's what? Cosine 2 theta. All right. So let's find the area. Okay. So our area of that region is equal to the double integral of dA, right? 1 dA. And that's what it said up here. It said the integral, this is your area. And, I guess, if we wanted to, I guess we could use that, we could use this formula. But let's just go ahead and set the whole thing up. Okay. All right. So this is equal to the double integral. So let's see, theta. Well, first r goes theta is on the outside here. So that's negative pi over 4 to pi over 4. And then our r is going from 0 to cosine 2 theta. All right. Now, and that's going to be what? R dr d theta. All right. Because 1 is just the 1, and then the dA is r dr d theta. So let's see what we get. So this is going to be negative pi over 4 to pi over 4. And then when we integrate this, this is going to be 1/2 r squared from 0 to cosine 2 theta. And then that's d theta, which is equal to negative pi over 4 to pi over 4 of 1/2 times cosine squared 2 theta d theta. All right. Now, let's look at this for just a second. Okay, let's look at it for just a second. So you see my h of theta is cosine 2 theta. You see that? That's h of theta. There's alpha, beta. 0 to h of theta. And look, remember what this said up here? If we have that, we got down here alpha to beta, so there's your negative pi over 4 to pi over 4, 1/2 h of theta squared. What was h of theta in our problem? It was cosine 2 theta. So you see, we got right to here. Okay? I mean, if you don't remember this, you need to set it up. And that's what we did. We started from here and went through, and we got to this point. Okay? All right. So now we need to work this out now, don't we? And I think what I want to do here, so I'll plug the cosine 2 theta in for r. I've got the 1/2. But what I want to do is I want to bring that 1/2 out. Okay, just pull that 1/2 out. And so that's going to leave us with 1/2 negative pi over 4 to pi over 4. Now, this right here, we did something like this earlier, but I think earlier we had sine squared, right? We had sine squared. But here we've got cosine squared. And remember, we've got cosine squared theta is equal to 1/2 times 1 plus cosine 2 theta. See, whatever this angle is, this one here's double that. And so you can see we got the 2 theta here. So when we convert that, that's going to be 1/2. So I'm rewriting this part right here, cosine squared theta. That's 1 minus cosine what? 4 theta d theta. All right? And I'm sorry, it's not minus, it's plus. All right? And so now let's go ahead and split these. Let's split them up. Okay, we'll do them each separately because I'm going to have to use U substitution on here. And so what I get now is I get 1/4 from negative pi over 4 to pi over 4 of d theta. See, that's 1 d theta. See, I got the 1/2 and the 1/2. That's where my 1/4 comes from. And then plus, and then the 1/2 is on this cosine also. So 1/2 and 1/2, that's 1/4. Negative pi over 4 to pi over 4. And then that's going to be cosine of 4, cosine 4 theta d theta. All right. And so now, well, that one's easy to integrate. With this one, I need to use U substitution. So I'm going to let U equal 4 theta. So du is equal to 4 d theta. And so notice I've got a d theta, but I'm missing the 4. So I can multiply by 4. So that means I have to come out here and multiply by 1/4. And now I got 4 d theta. 4 d theta, I can replace that with du. And so this is going to give me 1/4 theta from negative pi over 4 to pi over 4 plus 1/16. And that's going to be cosine u du. I'm making my substitution. And remember, since my variable is now in terms of u, I have to change my limits. Okay? And so I get u is equal to, let's see, that's going to be, if I plug in negative pi over 4, plug in negative pi over 4, that's going to give me 4 times negative pi over 4, which is negative pi, and u equals 4 times pi over 4, which is equal to pi. So that's negative pi to pi. And so this is going to give me 1/4 times, and that's going to be pi over 4 minus negative pi over 4. All right, that's for that. Plus 1/16, and that's going to be sine u from negative pi to pi. Now, I don't know if you can see this, but just look at it. Did you see that's right there is going to be 0? Because the sine of pi is 0 and the sine of negative pi is 0. So all that's going to be 0. I'll go ahead and write it down for you. And that's just 1/4 times pi over 2, pi over 4 plus pi over 4, plus 1/16. And that's going to be sine pi minus sine negative pi. You see that? All that's 0. And so I'm just left with pi over 8. And there's my answer. All right. All right, so, hopefully all this is making sense to you. So let's look at this, and I believe this is our last example. So it says, find the volume of the solid that lies under the paraboloid Z equals x squared plus y squared. So that's a paraboloid. That's opening up there above the xy plane and inside the cylinder, x squared plus y squared equals 2x. All right, so let's see if we can make a sketch of this. I can tell you right now it's not going to look good, but we'll see. All right, so there's x, there's y, and I have a paraboloid. There's my paraboloid. So it's under this paraboloid and above the xy plane and inside this cylinder. So where is that cylinder? Well, I've got what? I've got x squared plus y squared equals 2x. So that's x squared minus 2x plus y squared equals 0. Let's do this. Plus y squared equals 0. And I'm sure you have an idea what we're going to do. We're going to complete the square. So half the 2 and square it, that's 1. So we've got to add over here. So that's x minus 1 squared plus y squared equals 1. All right. And so the center is going to be out here at 1, 0, and the radius is 1. So we've got a circle like this, and we've got the cylinder coming up like this right here. And so there's your cylinder, and it's find the volume of the solid that lies under this paraboloid above the xy plane and inside this cylinder here. So it's and I know I'm going to butcher this when I draw it, but I'll draw it the best I can. It's going to be something, I don't know, something like this right here, this circle here. That's where they intersect. Okay, and if we look at this, okay, this is a circle centered at 1, 0. That's 1. That's 2. It has a radius of 1, so we know it touches right here. All right, and so we've got the integral over the region D, x squared plus y squared dA is equal to, now look, so think about this. All right, so I need to get my theta. I need to get the bounds on my theta. Okay, so can you see that see how we're right here and here? That's going from what? Negative pi over 2 to pi over 2. So that's negative pi over 2 to pi over 2. Now, I need the bounds on R. And so obviously you can see we're going from here to here. You see how that, as theta's going around, that radius is changing, isn't it? It's changing to whatever this is. Well, what's the equation of that circle? That's what we need. But we know we're going from 0 out to this curve here. So what is that? I need it in polar form, right? So how do we get that? Well, isn't this the equation of this circle? See, I completed the square on it. There's the equation of that circle. So I know I've got x squared plus y squared equals 2x. Well, what's x squared plus y squared? That's r squared equals 2 times x. Well, what's x? That's r cosine theta. And so I know r is equal to 2 cosine theta. All right, and so that's 2 cosine theta, and that's of what? Well, now I need to take this, convert it to polar form. So x squared plus y squared is r squared times r dr d theta. All right. So a lot of times on these, that's going to be the toughest thing to do. So, you know, some of the time is just setting up the integral. All right. All right. So this is going to give me negative pi over 2 to pi over 2 of 0 to 2 cosine theta r cubed dr d theta. So now we need to integrate this thing. All right, so this is going to give me negative pi over 2 to pi over 2 of 1/4 r to the 4th from 0 to 2 cosine theta d theta. And so now let's plug everything in. All right, so this is going to be negative pi over 2 to pi over 2 of 1/4. And, you know, I think what I'm going to do here at this time, I'm going to bring that 1/4 outside. Okay, we can pull the 1/4 outside. Well, let's just, I don't know, it doesn't matter. I'll just leave it in. That's fine. And so that's going to be cosine, that's going to be 2 cosine theta, and that's to the 4th d theta. And so let's clean this up a little bit. Negative pi over 2 to pi over 2. Now this is going to be what, 16? You see that? 2 to the 4th is 16. 16 times 1/4 is 4. So let's bring the 4 out now. I mean, like I said, it wouldn't have mattered if we would have brought the 1/4 out there, or waited and multiplied and brought the 4 out. It's all going to be the same. And that's going to be cosine to the 4th 2 theta d theta. All right, so now we get the fun task of integrating that thing. All right. Well, I don't know anything about cosine to the 4th, of how I need to go about integrating cosine to the 4th. But what I do know how to integrate, and we did it in these previous ones, is I do know something about, where is it? Cosine squared. Okay, I do know something about cosine squared. So what I'm going to do is I'm going to rewrite this as 4 negative pi over 2 to pi over 2 of cosine squared. Why in the world did I write 2 theta there? That's just cosine theta. Cosine theta. All right. And remember, that's all squared d theta. Okay. All right. So what do we have? Well, that is going to give us what? That's going to be 4 negative pi over 2 to pi over 2. All right. So let me back up just a second. So what we're doing right now is perfectly fine. We can keep going like this. Okay? But let's do this. I know that this thing is symmetrical, right? I know it's symmetrical. So if I do just this top half and then double it, that'll give me the whole thing, right? I can go from negative pi over 2 to pi over 2, or I can go from 0 to pi. You see that? From 0 to pi. So let's do that. Is it going to make it easier? I don't know. It might, but I won't have to deal with pi over 2 and negative pi over 2. I can deal with 0 down here. that's something that you might want to consider if you've got something symmetrical like that. Is make the limit 0 if you can. And so to do that, I would have to do what? I would have to go from 0 to pi over 2, and that's going to be what? Cosine squared theta and all that squared. But before I do that, this is going to be what? That's going to be 8 out there, right? Because instead of going from negative pi over 2 to pi over 2, I'm going to go from 0 to pi over 2, so that means I have to double it. So 2 times 4, that gives me the 8. Okay? All right. And then this is going to be what? This is going to be 1 plus cosine theta. No, 1 plus cosine 2 theta over 2, all of that squared d theta. So you can see there's a lot of, well, we're having to do a lot of rewriting stuff here in this one. And so that's the 1/2 times that. I just put the 2 underneath. Same thing. And so the 2 squared, that's 4, right? And if I bring that 1/4 out here, 8 over 4, that's going to leave me with 2, 0 to pi over 2. And then if I multiply 1 plus cosine 2 theta times 1 plus cosine 2 theta, that is going to give me 1 plus 2 cosine 2 theta plus cosine squared 2 theta d theta. All right. All right, so moving along. So I did that, but I still have this. Okay, so I still have a problem right here. I've got cosine squared. So I need to do it again to this one. And so this is going to be 2, 0 to pi over 2 times, and that's going to be 1 plus 2 cosine 2 theta plus, and then rewriting this, that's going to be 1/2 times 1 plus cosine of what? 4 theta, right? D theta. All right, because remember, this angle is going to be double this one, so that's where the 4 theta comes from. All right, so let's go ahead and split all this up. Okay, I'm going to integrate each term individually. And so this is going to be 2, 0 to pi over 2 of d theta, right? 1 d theta plus, and that's going to be, let's see, that's going to be 4 integral. See, the 2 times the 2, that's going to give me 4 from 0 to pi over 2 cosine 2 theta plus, now look, I got 2 and 1/2 is just 1. So I'm going to be distributing a 1 to each of those. See, the 2 times the 1/2. So that's going to be times 1 plus 0 to pi over 2 d theta. And then that's going to be plus 0 to pi over 2. And that's going to be cosine 4 theta d theta. All right. And I could actually combine these two. You see that? That would be 3. The integral of 3 times the integral of 0 to 2 pi d theta. I could do that. And let's just go ahead and do that. So that's going to be 3, 0 to pi over 2 d theta plus 4 integral 0 to pi over 2 cosine 2 theta d theta plus 0 to pi over 2 cosine 4 theta d theta. All right, so let's integrate. So this one's easy, okay? This one and this one, we're going to have to use substitution. And so for this one, I'm going to let u equal 2 theta. So du is 2 d theta. And so you can see I'm missing a 2, so I got to divide by 2. All right. Over here, I'm going to let, instead of using u, we'll use w. Let w equal 4 theta, so we don't get the u's mixed up. And so W is 4 theta, so dW is 4 d theta. You can see I'm missing a 4. And so multiply by 4, then I've got to go outside and multiply by 1/4. And also, let's keep in mind, we're going to have to change our limits on each one. So for the limits on this one, I've got u is equal to 2 times 0, which is 0, and u equals 2 times pi over 2, which is pi. And over here, I got w is equal to 4 times 0, which is 0, and w is equal to 4 times pi over 2, which is 2 pi. All right. And so this, I'm going to go ahead and integrate that. That's going to be 3 theta from 0 to pi over 2 plus 2 times the integral. That's going to be 0 to pi of cosine u du plus, and that's going to be 1/4 from 0 to 2 pi of sine, not sine, of cosine u du. All right, so that's going to give us 3 theta. Well, let's just go ahead and evaluate that one. So that's going to be pi over 2 minus 0 plus 2 times, and that's going to be sine u from 0 to pi plus 1/4 sine u from 0 to 2 pi. And this is equal to 3 pi over 2. Now, I'm not gonna write this out. I have a couple of times in the video, but look, plug the pi in. Sine of pi is 0. Sine of 0 is 0. That whole term's going to 0. Sine of 2 pi is 0. Sine of 0 is 0. All of that's going to 0, and you're left with 3 pi over 2. Okay. So that's that problem. All right. So, and that's the end of the video. So that problem, see, it's a little work setting these things up, but then as you can see in this last problem, it can involve quite a bit of work. You've got to be up on your trig identities and, be able to simplify all this stuff. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.